Hello everyone, in this video I'm going to show you how to take the text file you created with HLS-Meta and I'm going to show you how to import it into Excel so you can see the data you inputted as well as the output data, which would be the effect size data. Also in this video I'm going to show you a temporary fix for this file. Right now we're working on fixing this within the program itself, but currently there's an issue with the experimental versus control effect size data, so we are going to have to show you a manual way to get that data and fix that problem through Excel, and it's going to be a quick and easy fix, and I'll show you that in a few minutes. Just to let you know and show you, right here is our file. This is the file we created with HLS-Meta. Yours is going to be in whatever directory you put it in, obviously, and whatever the file name was. So we're going to go over here, we're going to open up Excel. And we're going to navigate to wherever that file is. Here it's in the test files folder. As you can see, it doesn't show up here. It's because it's a text file. So what you have to do is you have to click down here. Excel's automatically just looks for Excel format. You have to find the text file format, which is .txt. You're going to open up this. Now this is important. You need to click delimited on this screen. Next. You're going to unselect tab and you're going to select comma. As you can see, this splits up all the data you entered. See how it's all one group, and then you click this and it splits up everything. This is why you can't use commas within the program itself when you're entering data. And then this screen, you don't have to do anything. So what you have here is the data we entered in when we did our study example. This top row is always going to be just the categories for each column. So we'll underline that so you can see. This is the manuscript ID, which is the arbitrary ID label that we use to categorize our studies. You may or may not have this. You may have your own classification system. It's arbitrary identifier. The reference category is going to be the author and the year. The stats is going to be what kind of stats it is. In this example, it's means and standard deviations, and it's for the design, which is two groups, pre-test, post-test design. And the subgroup for this is going to be the HIV group versus the control group. And as you can see as we go along here, these are all things you entered within the program. And basically what it did is it just outputted it into a format to be put into Excel. So you look over here, and it has the different follow-ups we entered. 0 post-test, the first follow-up, which was 12 weeks, and the second follow-up was 24 weeks. And each row corresponds to that follow-up. So this is the post-test row, the 12-week row, and the 24-week row, pre-test, post-test comparison. And these are all, in this case, the measure is going to be number of partners. In our example, we left outcome blank, the control variables blank, because there were no control variables, and we don't have an outcome classification system for our purposes right now. We're just using this as an example to show you how the program works. I'm going to highlight a couple things here for you. Highlight this. I'm going to highlight this. So keep in mind, this is the means and standard deviations pre-test, post-test design. I'm going to freeze these rows. So what you have here in yellow is all experimental data that you input into the program, and here's all the control data that you input into the program. So just going column by column, this is the sample size pre-test column, the mean pre-test column, the standard deviation pre-test column, the post-test sample size, post-test mean, and the post-test standard deviation. So as you go along here, you can see this data all corresponds to the experimental group pre-test and post-test, pre-test and 12-week follow-up, and pre-test and 24-week follow-up. And obviously the pre-test is going to be the same every time. And you're going to have the same information for the control over here. So This is all pretest data, identical for each row because the pretest is the same for all 3 follow-ups. And then this is the post-test data, the sample size, the mean, the standard deviation at post-test, 12-week, 24-week. So this is all the input data. So what you're going to get when you scroll to the right here is your output data. So this is what was actually calculated in the program. I'll zoom out a little bit and shrink some of these down so it's easier to see everything. So I'm going to highlight once again a couple things for everyone. Just using different colors so you can differentiate the experimental and control data. So what you have here in the green is the experimental data that was outputted. So this data, since it's pre-test, post-test design, 2 groups, this data in the green right here, this is going to be the pre-test, post-test data for the experimental. So the magnitude of change from pre-test to post-test in the experimental variable. So here we're looking at a number of partners. So this number is tracking the change from pre-test to post-test, pre-test to 12-week, and pre-test to 24-week, corresponding with the row for that outcome and that measure. So what this is going to tell you right here is if this row right here is the effect size, the D is the effect size, and EX indicates the experimental group. So what this is going to show you is whether the data or the variable increased or decreased over time. So as you can see, these are all negative numbers, and a negative number is telling you that the number actually went down over time. So if you look over here, it makes sense because you had a 1.25 and 1.11 mean at pretest and 1.04, 0.84 at follow-up. So the number went down. So this is good. You want to see negative in this case because it's number of partners. If this was a condom use measure and you saw negative for the experimental group, that wouldn't be good because it would be saying that condom use decreased over time. So this is something you want to see in this particular instance. And what else you have here is the variance for the experimental group, labeled here, the weight, and the lower and upper level of confidence interval for that row, and that effect size. And when you get over here, you're going to see the same information except for the control group. So this is the D, the effect size for the control group, which is why there's a C in parentheses on all of these. And this is going to do the same thing I was just explaining except for the control group. So a negative number is going to indicate a decrease in the variable, and a positive number is going to indicate an increase. So these are all negative numbers. So that's telling you in the control group also decreased. So we're going to go over here now, and we're going to highlight the last bit of data. And this is the part that needs to be fixed manually currently until we fix it ourselves within the program. The experimental versus control data is the calculator is not working properly. So I'm going to show you how to fix that, but I will explain these columns first. This is D, the effect size for the experimental versus control comparison. So this is going to compare the magnitude of change pre to post test in the experimental group to the magnitude of change pre to post test in the control group. So this is a good example because the experimental group here, they decreased their number of partners, but so did the control group. So if they both decreased, wouldn't you want to know who decreased more? Was the experimental group more effective than the control group? So what this number is going to tell you is, compared to the control group, what was the magnitude of change from the experimental compared to the control? So which one was more powerful? And you're going to have a D here, the effect size for that, the variance, the weight, and the confidence interval. So I'm going to show you a manual fix for this before I explain a little bit further. So we're going to minimize this a little bit. I'm going to show you this file right here is the one we're going to want. Open up Excel so I can show you the format. Now this EXP versus CTRL is the experimental versus Ctrl ES calculator fix. I'm providing a link in this video in the description so you can download this. So you'll just have to download that, and I'll show you how to download that in a moment. I'm actually going to take the link right here so I can show you how to get it. Like I said, this file is in the description. My password protected it just because you can do it and you might as well. And the password is capital H, capital L, capital S, dash meta. You're going to validate the password. And then the screen's going to pop up. So as you can see, this is the file that you just saw on my desktop. Click regular download. This is the one you don't have to pay for. You're going to go down here and you're going to click download file. As you can see, this is the file I just pointed out on my desktop, so you'll be able to get it through the internet. You're going to save that, and we're just going to overwrite it just to get it again. You can X out of this, so now you all have that file. So what you're going to want to do now is you're going to want to open up the file we just downloaded to the desktop. This way we can manually make the fix I was discussing. Now if you look down here, as you can see, this is actually in the same format as the output from HLS-Meta. This is our old calculator where our calculations over here were done manually within Excel. So it took the data from Excel and it calculated it. So like I said, you can see manuscript ID, reference, stats, design, pre-test experimental, post-test experimental, pre-test control, post-test control. So this is pretty much identical to what's being formatted up here. So what you're going to want to do is you're going to want to copy the information from this bottom Excel sheet to this one, to your output from HLS-Meta. So we're going to create a new tab. We're going to call it Calculator Fix. We're going to highlight these first 5 rows here. We're going to copy, and we're going to paste. We're going to paste special, and we're going to go to XML spreadsheet. So that's right click, paste special, XML spreadsheet. So now everything that was down here is up here. And since you did it as a spreadsheet, all of this copied over with formulas and not just the text. So now you no longer need this down here, this window down here. So you can X out of here. You can go full screen with this. And what you're going to want to look at is this information right here. These 5 cells. So as you can see, this is the D for the experimental versus control, the variance, the weight, and the lower and upper confidence interval. So going over here, you're going to see the same thing, D, variance, weight, lower, upper confidence interval. So these cells are where the error is. And these cells actually use the data from here, from the experimental pre-post and the control pre-post. And they use a formula. So you're going to just take these 5 cells, you're going to copy, you're going to go over to this, and you're just going to paste these in here. And now, as you can see, there's no longer numbers in here. Well, there's numbers on the screen, but if you look up here, the formula bar, there's actually formulas, and what it's doing is it's using these effect sizes from the experimental control group to calculate the experimental versus control group effect size. So now this is actually correct because the program outputs this data correctly and this data correctly and this data incorrectly, but now that we've provided a manual fix, this is going to be the correct data. So now you just have to be able to interpret what this all means. So there's D, the experimental versus control effect size, is going to tell you the difference between the magnitude of change pre-post in the experimental group to the magnitude of change between the pre-post and the control group. So they both were measured pre-post. So what is the magnitude of difference in their change? So did the experimental group change more than the control group, or did the control group change more than the experimental group, and in what directions? So this is a number of partners outcome. So what's going to be indicated here is if the experimental group decreased more than the control decreased, then you're going to get a negative effect size here. Or if the control increased more than the experimental increased, you're going to get a negative effect size here. Conversely, if the experimental increased more than the control increased, you're going to get a positive effect size. And if the control decreased more than the experimental decreased, you're going to get a positive effect size. So those are kind of 4 rules of thumb to remember as you're interpreting effect size. So in this instance, you're going to want the negative number to be greater. So the more negative you go, the better it is, because that means the experimental group decreased that much more than the control group. If this was a positive number, that would probably mean that the control group decreased more than the experimental group. And in this instance, that's not a good thing, because we want the number to go down. If this was a condom use outcome, and this is the effect size we were getting, this would actually be a bad thing, because it would be saying, well, the control actually did a better job than the experimental in increasing condom use. But it's number of partners, so the more negative you go, the better. Also important to remember is that these 5 cells right here, this experimental versus control ES data, it's going to replace all of the formulas for the design one, no matter what statistic it is, if it's using data from here and data from here. So if it's referencing these cells, if you're using pre-post data for experimental control group and you're getting effect sizes for them within HLS-Meta, you're going to need to recalculate this. Now, if there's something like an F-test in design 1 where you only use the experimental versus control ES and there's no effect size data here or effect size data here going over here, if there's nothing here and nothing here, then you're going to use what's outputted. You're going to use what's given, and you're not going to paste this over. But as long as there's this pre-post experimental and pre-post control effect size data being outputted by HLS-Meta, then you're going to need to replace the experimental versus control ES data. So now what you're going to want to do, now that you've created this file and finished it, you're going to want to look up here and see that this is a text file. So you want to preserve all the formatting, specifically this right here, the formulas you put into here. So you're going to want to save this as an Excel sheet when you're done. So you're going to go to File, Save As. As you can see, this is the folder I have the original file in that we have open right now, and you're going to want to click here where it says text, and you're going to change to Excel workbook, and you're going to save in this format. So now you look up here, it's now an Excel format, and you can exit out and open back up. See that this is exactly how we left it, and the formulas have been preserved here. That's going to be it for exporting your file to Excel.